And we're moving on. So chapter 6 is going to be introducing trigonometric functions to you, and chapter 7 will be a continuation of the discussion on trigonometric functions. So far in this course, chapters 1 and 2 were kind of getting you ready for some of the stuff, and it was really focusing on transformations, right? Understanding what a function is and how to do transformations. Then we moved into chapter 3, where we learned specifically how to solve quadratic and rational equations so that we could really start the course. So really starting the course was chapter 4 and this idea of how to solve polynomial functions and rational functions, as well as their inequalities. And then we went on to exponential functions, logarithmic functions, and now we're finishing with trigonometric functions for 2 chapters. And then we end with sequences and series, which is kind of its own thing. So we need to get all of our language on the same page. Some of this will be new, some of this will be review, but we're going to kind of just do it from a place where hopefully everybody will get caught up. So 6.1. We are going to look at trigonometric functions of acute angles. So an acute angle is any angle less than 90 degrees. To do this, you have to understand the parts of a triangle in terms of trigonometry. When we talk about the parts of a triangle, we talk about the opposite, the adjacent, and the hypotenuse. The easiest side to identify is always the hypotenuse because it is across from the 90-degree angle. It's your hippo, right? It's your longest side. Then opposite and adjacent are very specific to the triangle and the angle that you're looking at in that triangle. So in this triangle, we have angle theta. We often depict angles with Greek letters or with capital letters. So this is angle theta. And for this angle theta, this side here is opposite that angle. So that we call it the opposite side. And then this other side here that's left over is adjacent. It's adjacent means beside, and it's the side that's beside the angle that's not the hypotenuse. So what I want you to do now is pause the video, and I want you to label this triangle with hypotenuse, opposite, and adjacent. Okay, so I don't know where you started, but I would start with the hypotenuse. It's always across from the 90-degree angle. Then I go to the opposite side, so it's the side across from the angle in question, and the adjacent's the one left over. It's beside the angle that's not the hypotenuse. Okay, so now that we know opposite, adjacent, hypotenuse in a triangle, now we're going to start talking about your trigonometric functions. Now your base trigonometric functions are sine, cosine, and tangent. We call this SO, CA, and TOA as a little bit of a short form. What it means is that the sine of any angle is equal to a ratio of the opposite side across from the hypotenuse. The cosine of any angle is the ratio of the adjacent side to the hypotenuse. And the tangent of any angle is equal to the opposite side across from the adjacent side. What might be new to you is there's actually 3 more trig functions that we pretty much only talk about from a Math 60 level and up. We don't mention these in anything below because they're not useful. In fact, they're not even on a calculator, but they exist. It's the fact that, you don't have to look at a ratio of opposite to hypotenuse. What if you wanted to look at a ratio of hypotenuse to opposite? What about instead of adjacent to hypotenuse, you want hypotenuse to adjacent, and so on and so forth. So they are the reciprocals of your base trig functions. And how they're named is, I don't know if it's smart or not, but your base trig functions, you have a sine and a cosine. For your reciprocal trig functions, you have a cosecant and a secant. And the way they line up is that every pair gets a co. So sine goes with cosecant, and cosine goes with secant. So it would be nice if they just went cosine goes with cosecant, but it's not that way. So you just have to remember every pair, so every reciprocal pair will have a co, just like sine and cosine each have a co. Okay, and then tangent's nice because they've got tangent and cotangent. Makes it simple. So all of these reciprocal trig functions, the ratios are opposite. So instead of opposite to hypotenuse, you have hypotenuse to opposite. And you can also think of them as the reciprocal. Cosecant theta is the reciprocal of 1 over sine theta. Secant theta is the reciprocal of 1 over cosine theta. And cotan theta is the reciprocal of 1 over tan theta. So the first thing we're going to do is just practice writing these 6 trigonometric functions. And this one's specifying we want it of angle alpha. So we've got this angle here in question, and we want to write our 6 trig functions. So the first thing we're going to do is label our sides. So pause the video, take a minute, label your sides. Okay, across from the 90-degree angle, we have the hippo, right, the hypotenuse. Then across from the angle in question, we have the opposite. And then beside the angle in question, we have the adjacent, or the one left over. So now, if I was going to write the sine of alpha, I'm going to do opposite over hypotenuse. So 5 over 13. Now, without even looking at the triangle, I now know that cosecant of alpha is 13 over 5. All right, pause the video and keep going. So I want you to do cosine of alpha, secant of alpha, and so on and so forth. All right, so cos of alpha is adjacent over hypotenuse, so it's going to be 12 over 13, which makes the secant of alpha equal to 13 over 12. The tan of alpha is opposite over adjacent, so 5 over 12, which makes the cotan of alpha adjacent over opposite, or 12 over 5. All right, that's where we start. The next step up is we are going to have these 6 functions related when you know one. So what it is that you can find the 5 trig functions when only one trig function is known. How are we going to do this? Well, you're going to draw a triangle, you're going to label the sides, you're going to calculate the third side using Pythagorean theorem, and then you're going to find all 5 trig ratios. So here's my question. If sine beta is equal to 6/7 and beta is an acute angle, find the other 5 trigonometric functions values of beta. So to draw an acute angle, one thing I want to add on now, which I don't want to talk too much about, but we are actually going to be putting all of our angles into our into one of the quadrants. To be an acute angle, you're between 0 and 90. So if this is 0 degrees and this is 90 degrees, I'm going to draw my acute angle in this quadrant. Okay, so I'm going to say that angle beta is in here. If you want to leave out the quadrants and just draw a triangle, that's fine. But the more I can get you used to seeing things that are coming up now, it'll be less of a push to put them in there later. Now, from beta, I would label my sides. So from beta, this is my, well, I'll start with my hypotenuse. It's always across from my 90-degree angle. This is my opposite, and this is my adjacent. Okay, so they've given me that the value of sine beta is 6 over 7, which means that the opposite side is 6, and the hypotenuse side is 7. They've given me 2 of the sides of my triangle. I'm missing the third. To find the third, I'm going to recognize that this is a right triangle, and so I'm going to use Pythagorean theorem. So Pythagorean theorem states that the square of the hypotenuse is equal to the sum of the squares of the 2 other sides. Or if you want to find a side, it would be a squared equals c squared minus b squared, or b squared equals c squared minus a squared. It doesn't matter. So here I'm solving for a side. Let's call it x. To solve for x squared is going to equal the hypotenuse squared minus the other side squared. Simplifying this, I have 49 minus 36, which is 13, but that's equal to x squared. I'm solving a quadratic equation here, and I'm going to solve it using the square root property. When I take a square root, there are always 2 answers, plus or minus root 13. Now at this point in the course, we are just talking about lengths of sides of triangles, so we're only going to accept the positive answers. But as we move through the course, we're going to be wanting those negatives. So if we mention it now, get it into practice, there's always 2 answers, plus minus, and then you choose the one you want, the better off we'll be. Now we want to find the 5 trigonometric values of beta. So we already know that sine beta is equal to 6 over 7, which means we also know that cosecant beta is 7 over 6. What we now need to find out is the other 4. So let's start with cos beta. Cos beta is equal to the adjacent, which we just found was root 13. Let's write that on our triangle, root 13. Okay, adjacent over hypotenuse, which is 7. The secant of beta is the reciprocal, or hypotenuse over adjacent, so 7 over root 13. Now, in other courses I've taught, they've been okay leaving it like that, but most of these textbooks really like to be proper, which is actually amazing. And you have to recognize that you are not allowed to have a radical in the denominator. So we are going to rationalize this denominator by multiplying the numerator in the denominator by the radical in the denominator, so by root 13. So this is actually going to be equal to 7 root 13 over 13. So it's an expectation that when you give a ratio that it will have a rationalized denominator. So now I want you to pause the video and I want you to solve for tan beta and cotan beta. So tan beta would be opposite over adjacent, so 6 over root 13, which you would rationalize by multiplying by root 13 over root 13, and you would get 6 times root 13 over 13. Okay? The denominators will never get trickier than this, right? They're always going to be these monomial denominators where you just multiply by the radical in the denominator. Cotan beta is going to be adjacent over opposite, or root 13 over 6. And that's it. So go and practice that. I've just given you 3 questions to practice, and hopefully you'll feel pretty confident with it.